we're going to look at a problem that looks like it could be a possible common high school problem, but what we're going to find out is this is a fairly involved problem, but I want to work through it, and I want to work through it with exact types of answers and not use calculator answers, and just to show how this process can work. So the first thing we need to do is attempt to get rid of these logarithms. And we notice that each is a base 9, so that's good. They have matching bases. So what we want to do is take this left-hand side and this right-hand side and push it up into the exponent position of 9, since that's the base, and those will cancel out. So we have this going on, and now this 9 and this exponent of log 9, they cancel, and it's going to leave us with just the x to the 4th minus 3. Same on the right hand side, the 9 and this log 9 cancel, leaving us just the 15. And so this is going to leave us x to the 4th minus 3 equals 15. And at this point we have a couple options in how we want to solve this. The first thing to do might be to bring the 15 over to this side. The other option would be to take the 3 over to this. Alright, so this is a look at our two options. If you're looking at this, you're looking at a polynomial equation and you're looking for the roots. So the solutions, we have a sketch that's going to look something like this. It is symmetric about the y-axis, and this root is going to be the same distance as this root from the y-axis if this is centered at the y-axis. So this tells us we have plus or minus some root number. We also see that there's two places that we actually see this cross the x-axis, so the anticipation is that we have two roots that are going to be complex answers. So let's look at option 2 first. The easy way to look at solving this would be take the 4th root of both sides, and so we have x equals the 4th root of 18, and that's going to be plus or minus that. That's these real roots that we see here. And that's kind of the straightforward look. The thing that's not as straightforward is where the complex numbers come in. One observation we want to make over to the side is that I to the 4th power is going to equal 1. How do we get that? Well, we have 4 i's. I times I is going to be negative 1. So we really have two sets of negative 1s. Negative 1 times negative 1 is positive 1. So the 4th root of 1 is going to be I. Taking a look at what we have over here, if we factor 1 out of 18, we have 18 times 1. That's still 18, so we're good there. If we take the 4th root of the 1 and consider it I, then the next set of roots that we can have is plus or minus I 4th root of 18. And so we have this as our other set. And so here are 4 solutions. Now you may want to go back and verify that negative I to the 4th power is 1 also, since I claim that plus or minus this is a solution. Now, going over here, I'm going to use an idea from over here in what I do over here. What I want to do is I want to divide out these roots from this, with the idea that I'm going to use this and these roots that I knew to find these two roots which I claim I know. So for those of you who like really solid examples and not this kind of hand-wavy type of answer, you're going to like this one. And so I want to set up some synthetic division. So I'm going to write this polynomial out longhand first so I see all the coefficients, and then I'm going to set up my synthetic bracket. Alright, this is written out longhand, and I'm just dropping each of these coefficients down here into my synthetic bracket, and I'm going to divide by the positive root here. And this should give me a 0 in this last position here. And if you haven't seen this before, we're adding in columns this way, and then we're multiplying as we round the bin this way. So I have 1 plus nothing is going to be 1, and then I have the 4th root of 18 times 1 is going to be the 4th root of 18. adding that to 0, I end up with the fourth root of 18 down here. And then I'm going to multiply the fourth root of 18 times the fourth root of 18. And this will be the fourth root of 324. And I'm adding these, so this is also the fourth root of 324. And then I'm going to multiply the fourth root of 18 by the fourth root of 324 to get the fourth root of 5,832. And then add these together. This is the fourth root of 5,832. Then I multiply this times this, and this is where it turns out nicely because that's simply going to be positive 18. Since I've multiplied this by itself 4 times, essentially, it just brings me back to 18, and so this is 0. So now I'm going to continue my synthetic division here with these 4 terms here. This is the depressed polynomial after I divided this, and I'm going to divide by the negative version of this. This was the other root that I found over here. So these are the 2 real roots that I'm dividing by. So I just repeat this process again, and I'm going to get 1 down here, and then I'm going to have negative fourth root of 18, and I add these 2 together, and I get 0 here. So that turns out nicely. So I have this times 0 is 0, and I add those together, and I get the fourth root of 324 here. I multiply this by this, and I'm going to get the negative version of the fourth root of 5,832. And so that's 0 again. So this is a depressed polynomial, and it's done twice here. So this is really a quadratic. So this is an A, a B, and a C value that I can plug into the quadratic equation. And so I want to do that. I want to set this up as x equals plus or minus. Since my B is 0, I don't need that leading B out front there. I will put the 0 in here just so we see the placeholder there. And I'm multiplying these terms out here. And I'm dividing by 2. A is 1, so that's why this is just 2 here. And then I forgot to go through several steps of simplification. So as I simplify this, this is plus or minus the square root of negative 4 times the fourth root of 324 divided by 2. And then if I start to break this down, I find out that this is 3 times the fourth root of 4. So I'm going to multiply that out with the negative 4. Okay, so this is going to give me plus or minus the square root of negative 12, fourth root of 4 divided by 2. Okay, so at this point you probably want to do some side work with this to figure out what's going on here. So in the numerator here, I just want to write this out. Negative 12, fourth root of 4. And I want to rewrite this with exponents. What I have going on here is I have negative 12 times 4 to the fourth root, and all of that is to the half root. And so this is going to be negative 12 half times 4 to the 1/8. And so if I, oh no, this is a 2 here, the half. If I take the square root of negative 12, which is what the half power means, then I have 2i square root 3. And then this is times the 8th root of 4. Alright, so that's going on in the numerator here. So I have plus or minus 2i square root of 3 and the 8th root of 4, and that's divided by 2. This 2 and this 2 are going to cancel out since this is a product. So that leaves me with plus or minus I square root of 3, 8th root of 4. All right. So now you may be questioning, how does this relate to this that I penciled in up here as the idea of what I'm looking for? Well, we need to make some slight changes here to figure out if this is equivalent to this that I penciled in here. We have the 1 out here, but can we rewrite the square root of 3 so that it's something to the 4th root of something? And we can. So we have I, and this is going to be the 4th root of 9, and you can check that. If you take the square root of this twice, you should get the same as the square root of 3 one time. You can do that in a calculator if you don't follow that. And then I want to rewrite this as the 4th root of 2. So now I can, since these are both the same root here, I can combine those as plus or minus I to the 4th root of 9 times 2, which is equal to I times the 4th root of 18. And that's what I had penciled in up here before. So these are the two roots that we were looking for. So we have a couple different forms that are algebraically equivalent, so it depends on where you landed and where you want to be. So we have two options. Essentially, I used part of option 2 and option 1 to find this, just to verify that maybe some of your intuition was correct in finding this answer. So there's a couple of different ways to look at solving this problem, which looks like it could be a typical high school problem, but yet it has some very involved answers here, which students don't always want to find manually in this exact detail. I see a lot of calculator use on this kind of thing, and you get a lot of decimal answers which have to be rounded or truncated or somehow inaccurate, and we have very precise answers in what we have here or in the option that we found in any of these algebraic equivalents. So there's a nice exact answer. Cheerful calculating.